This is Voyager 1, and after decades, it has turned back and made a terrifying discovery. Since 1977, Voyager 1 has been hurtling through the vast expanse of space, sending back valuable data and images of planets, moons, and other celestial objects. Recently, however, Voyager 1 made a discovery that has sent shockwaves through the scientific community. After turning back towards our solar system, the spacecraft detected something that defies our current understanding of the universe. This discovery has left scientists both excited and terrified, as it could challenge our fundamental understanding of the cosmos. What did Voyager 1 discover, and what potential consequences could it have on our understanding of the universe? Voyager. This is the observable universe, and in 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2, on a mission to explore the outer reaches of our solar system and beyond. These missions were not only a remarkable feat of engineering and technological innovation, but also a testament to the human curiosity and our desire to explore the unknown. The Voyager missions were the result of years of planning and development by a team of scientists and engineers at NASA's Jet Propulsion Laboratory in Pasadena, California. The idea for the mission was conceived in the late 1960s when NASA scientists realized that the alignment of the outer planets would allow for a rare opportunity to send a spacecraft on a grand tour of our solar system. The Voyager spacecrafts were designed to take advantage of this alignment and explore the outer planets Jupiter, Saturn, Uranus, and Neptune in a single mission. The spacecraft were equipped with a range of scientific instruments that allowed them to study the planets and their moons in unprecedented detail, including cameras, spectrometers, magnetometers, and particle detectors. But the Voyager missions were about more than just exploring our solar system. They were also a message to the universe, a message in a bottle, if you will. Each Voyager spacecraft was fitted with a golden record that contained sounds and images of life on Earth, including music, spoken greetings in different languages, and even the brainwaves of a woman in love. The idea behind the golden record was to give any extraterrestrial beings who might come across the spacecraft a glimpse of life on Earth and our civilization. It was a way to share our culture and our existence with the universe. Sending the Voyager spacecrafts into space was no small feat. The missions faced a number of significant hurdles, including technical challenges, budget constraints, and political pressure. One of the biggest technical challenges was designing a spacecraft that could survive the harsh conditions of space and continue to function for decades. The Voyager spacecrafts were designed to operate for 5 years, but thanks to careful planning and engineering, they've continued to operate for over 4 decades. Another major hurdle was funding. The Voyager missions were not cheap. They cost over $685 million in today's money. At a time when NASA was facing budget cuts and scrutiny from Congress, funding the missions was not a sure thing. Despite these challenges, the Voyager missions went ahead, and they have been hailed as one of NASA's greatest achievements. The missions have provided us with a wealth of information about our solar system, including detailed images and data on the outer planets and their moons. Some of the most significant discoveries made by the Voyager spacecraft include the discovery of active volcanoes on Jupiter's moon Io, evidence of a subsurface ocean on Jupiter's moon Europa, and the first detailed images of Saturn's rings. But perhaps the most significant aspect of the Voyager missions is the message they send about human curiosity and our desire to explore the unknown. The Voyager spacecraft have traveled further than any other human-made object in history, and they continue to send back valuable data and images from the far reaches of our solar system. But this recent discovery by Voyager has scientists and researchers' heads turning. Heliopause. After over 4 decades of incredible space exploration, Voyager 1 achieved a historic milestone in August 2012 when it crossed the boundary known as the heliopause. The heliopause marks the outer edge of our solar system, where the influence of the sun's solar wind gives way to the interstellar medium. This momentous event was a testament to the resilience and endurance of the Voyager spacecraft, but what made it even more intriguing was the absence of any expected signs as Voyager 1 crossed this cosmic threshold. The heliosphere is a vast and dynamic region of space that encompasses our entire solar system. It's shaped by the influence of the sun, which emits a constant stream of charged particles called the solar wind. This wind extends far beyond the orbit of Pluto and forms a protective bubble around our solar system known as the heliosphere. The heliosphere acts as a shield, deflecting most of the harmful cosmic rays that originate from outside our solar system. These cosmic rays are high-energy particles, such as protons and electrons, that can pose a threat to astronauts and sensitive electronic equipment. The heliosphere acts as a protective barrier, mitigating the impact of these cosmic rays and preventing them from reaching the inner regions of our solar system. The shape of the heliosphere is influenced by the balance between the outward pressure of the solar wind and the pressure exerted by the surrounding interstellar medium. The interstellar medium is the sparse collection of gas, dust, and cosmic rays that fills the space between stars. As the solar wind interacts with the interstellar medium, it forms a boundary known as the heliopause. The heliopause is the outer edge of the heliosphere, where the pressure from the interstellar medium becomes dominant over the solar wind. It's the point at which the influence of our sun gives way to the vast expanse of interstellar space. The exact shape and structure of the heliopause is not fully understood, and ongoing research, including data from the Voyager spacecraft, continues to shed light on its characteristics. Inside the heliosphere, the solar wind flows relatively smoothly, with variations caused by the sun's activity, such as solar flares and coronal mass ejections. Beyond the heliopause, the interstellar medium exerts its influence, creating a more turbulent and dynamic environment. Scientists had anticipated that Voyager 1 would encounter distinct changes in its environment as it reached the heliopause. They expected a significant decrease in the intensity of charged particles from the sun, a shift in the direction of the magnetic field, and an increase in the density of interstellar particles. However, as Voyager 1 ventured beyond the heliopause, it did not detect the dramatic shifts that had been predicted. The lack of expected signs posed a significant puzzle for scientists. It changed their understanding of the boundary between our solar system and interstellar space. However, despite the absence of clear indicators, researchers have continued to analyze the data sent back by Voyager 1 to unravel the mysteries of this uncharted territory. One possible explanation for the unexpected observations is that the transition across the heliopause is more gradual and complex than initially thought. The boundary between our solar system and interstellar space may not have clear-cut boundaries, but rather a region of intermixing turbulence. The interstellar medium might have a more intricate structure than previously imagined, affecting the behavior of charged particles and magnetic fields in this transitional zone. If you're liking the video so far, make sure to subscribe to the channel and watch our previous videos to stay amazed. Scientists also speculate that Voyager 1 might have crossed the heliopause at a particularly quiet time in the solar cycle, which could explain the absence of anticipated fluctuations. The sun's activity, including the ebbs and flows of its solar wind, follows an 11-year cycle, and Voyager's crossing coincided with a period of minimal solar activity. This could have contributed to the subdued observations as the spacecraft transitioned into interstellar space. Following the remarkable achievement of Voyager 1 crossing the heliopause in 2012, its companion spacecraft, Voyager 2, embarked on a similar journey and crossed this cosmic threshold in November 2018. Like its predecessor, Voyager 2 encountered a surprising lack of anticipated signs as it ventured into interstellar space. Scientists had expected Voyager 2 to observe similar changes to those detected by Voyager 1 when it crossed the heliopause. These changes included a decrease in the intensity of the solar wind, alterations in the magnetic field detection, and an increase in interstellar particle density. However, much to the bewilderment of the scientific community, Voyager 2 reported a similar absence of dramatic shifts in its environment. The puzzling lack of anticipated signs suggests that our understanding of the heliopause and the transition from our solar system to interstellar space required further refinement. It became clear that the boundary between the two realms is more complex and dynamic than previously envisioned. It challenged scientists to reevaluate their models and theories to better comprehend this mysterious region. Despite being launched over 4 decades ago, these resilient explorers have defied the test of time, and their continued operation serves as a testament to the ingenuity and durability of their design. Obsolete yet working. When Voyager 1 and Voyager 2 were built, they were equipped with cutting-edge technology for their time. However, the rapid advancement of technology means that the instruments and systems aboard these spacecraft are now considered outdated. The onboard computers, memory storage, and data transmission capabilities of Voyager are far surpassed by even the most basic modern-day devices. Nevertheless, these venerable spacecraft continue to function and send back valuable data from the furthest reaches of our solar system. How is this possible? One reason is the simplicity and reliability of their design. The engineers who built Voyager prioritized durability and redundancy, ensuring that the spacecraft would withstand the harsh conditions of space and continue to operate even if some components failed. Another crucial factor is the resourcefulness and expertise of the mission team at NASA's Jet Propulsion Laboratory. Over the years, the team has demonstrated remarkable problem-solving skills, finding innovative ways to address challenges and keep the spacecraft functioning. They have devised workarounds, employed creative software updates, and utilized alternative methods of data transmission to adapt to the limitations of the outdated technology. Furthermore, the environment of space has actually been advantageous in preserving the functionality of the Voyager spacecraft. In the cold and airless conditions of deep space, with no atmospheric corrosion or exposure to damaging elements, the hardware has been able to endure longer than anticipated. The continued operation of Voyager 1 and 2 is a testament to their enduring legacy and the lasting impact of their missions. As they venture deeper into interstellar space, these aging pioneers provide us with invaluable insights into the dynamics of our solar system and its surroundings. What do you think of this discovery? Let us know in the comments section below, and make sure to like the video.